So what's up guys? So for today's video, we will discuss the living in the IT era. In Module 1, it discussed the overview of living in the IT era, the four basic computer periods, the pre-mechanical age, mechanical age, electromechanical age, and the electronic age. In pre-mechanical age, humans first started communicating. They would try to use language to make simple pictures, petroglyphs to tell a story, map their terrain, or keep accounts such as how many animals one owned. In mechanical age, the human start to see the connection between the current technology and its ancestors. The mechanical age can be defined as the time between 1450 and 1840. This era of the technology became the start of technological innovation in the interest of computer and information. In electromechanical age, it is the beginning of telecommunication as we know it today. This age is defined roughly as the time between 1840 and 1940. In electronic age, this machine used electronic switches in the form of vacuum tubes instead of electromechanical relays seen in the previous era. In principle, the electronic switches would be more reliable since they would have no moving parts that would wear out, but the technology was still new at that time and the tubes were comparable to relays in reliability. The major benefit of electronic switches was they could open and close thousands of times faster than relays. In Module 1 also, it discussed the generation of computers. In first generation, they created a vacuum tubes. In second generation, they created a transistors. In third generation, they created a integrated circuit. In the fourth generation, they created a microprocessors. In Module 2, it discussed the mechanical age of computer, the different invention during the mechanical age of computing. It discussed here the slide rule, that is device used for multiplying and dividing. It discussed also here the Pascal line. Other invention on this period includes invented by Blaise Pascal, a mechanical computer capable of adding, subtracting, multiplying, and dividing two numbers. It discussed also here the different invention during the electromechanical age of computing, such as telegraph, telephone, radio, and etc. In Module 3, it discussed the electronic age of computer. So there are the first generation of digital computer all used in vacuum tubes. First is the Atanasoff Berry computer. Second is the electronic numerical integrator and computer, or what we call ENIAC. Next is the electronic discrete variable automatic computer, or what we call EDVAC. Fourth is the Colossus. Fifth is the Zeus machines. And the last one is the Manchester Mark I. So let's proceed now in the module 4. The transistor and the integrated circuit age of computer. The evolving technology of second generation computer and third generation computer. In second generation computer, the early computers were large, bulky machine taking up the size of large room. They contained thousands of vacuum tubes. One and these tubes consumed large amount of power and generated a vast quantity of heat. These lead tubes burned out each day. This meant the machine were often non-functional for part of the day until the defective tube was identified and replaced. And third generation the first computers used thousands of vacuum tubes and they were large bulky machines. The invention of the transistor was a revolution in computing and it led to smaller, faster and more reliable computers. However, it was still a challenge for engineers to design complex circuits as they had to wire hundred thousands of separate components together. In Module 4, it discussed also here the invention of integrated circuit. The electronics industry was dominated by vacuum tube technology up to the mid 1950s. However, vacuum tubes had inherent limitation as they were bulky and unreliable, produced considerable heat and consumed a lot of power. Bell Labs invented the transistor in the late 1940s, and transistors were tiny in they were more reliable and last longer. The transistor circuits and equipment containing hundreds or thousands of discrete components such as transistor, diodes, rectifiers, and capacitors. So this is the first integrated circuit. So Kelby's integrated circuit consisted of a transistor and other components on slice of germanium. His invention revolutionized the electronics industry, and the integrated circuit is the foundation of almost every electronic device in a use today. His invention used germanium, and the size of the integrated circuit was 7 by 16 by 1.16 inches. So in Module 5, it discussed the microprocessor age of computer, the modern architecture of computers, and the fourth generation computers. So it discussed here that modern computers still use microprocessors until this time. In this age of computer, mini computers are computers that we use in our daily lives. From 1990 to today is generally labeled the fifth generation of hardware and software. In hardware, this period includes parallel computer or parallel architectures where a number of CPUs can be applied to the same task simultaneously. Some of the characteristic features of the fifth generation of computers is focus on AI or artificial intelligence, which is something related to use of computers to carry out tasks that are analogous to human behavior. It can be process images and graphic in the same way with word processing. For example, can see and understand a photo. Much faster information processing. The electronic component uses the most recent form of the VLCI chip. This generation of computers is still in the development stage, and there aren't many users yet. In Module 6, it discussed the Intel and AMD processors. This module will discuss the history of Intel and AMD microprocessors. So microprocessor is a central part of modern personal computer or a computer device. It integrates the function of a central processing unit onto a single integrated circuit and place a vast amount of processing power in a tiny space. Intel's invention of the microprocessors in 1971 was a revolution in computing, and it placed the power of a computer on a tiny chip. It was initially developed as an enhancement to allow users to add more memory to their units. However, it soon became clear that the microprocessor had a great potential for everything from calculators to cash registers and traffic lights. Its invention made personal computers, tablets, and mobile phones possible. So as you see in the screen, this was the world's first microprocessors, and although it was initially developed as an enhancement to allow users to add more memory to their units, it soon became clear that the microprocessor could be applied to many other areas. This small Intel 4004 microprocessor chip was launched in late 1971, and it could execute 60,000 operations per second. The tiny chip had an equivalent computing power such as ENIAC with the use of 18,000 vacuum tubes and took up the space. As the age of computing is developing, computers are becoming smaller yet considerably faster. One of the most important components in all our devices is the processor. Intel is one of the major processor companies and by far the most popular. Their latest processor have been the Intel Core i3, i5, and i7. These processors have been around for a while, but they still give machine buyers a headache. Which is the cheapest processor? Which one do you really need, and what is the difference anyway? Generally, a Core i7 is better than Core i5, which is torn is better than a Core i3. So in this module also, the AMD is born. From its conception in 1969, AMD focused on producing microprocessors and similar computers components. Initially, it merely licensed processor design from other companies like Fairchild Semiconductor. Although it started producing PC components developed in-house early on as well, AMD would wouldn't produce a processor it designed itself for several years. So over the years, AMD has continued to innovate and release new products such as the Ryzen and the Peer processor, which have been well received by consumers and industry experts alike. AMD's processors are now used in a wide range of devices, including desktop and laptop computers, gaming consoles, and data center servers. So overall, AMD's history is one of innovation, competition, and evolution, and the company continues to be major player in the semiconductor industry. So in Module 7, it discussed the internet, the modern architecture of computers in the present age. So we will discuss now what is the internet. So the internet is actually a collection of LANs and WANs connected to form a giant one. When you connect your computer to your internet service provider, you become part of this one. You have already learned much of the history of the internet. From a small beginnings, the internet has evolved into a massive network that involves nearly every computer in the world. Understanding the internet requires understanding many of the technologies that make up the whole. These technologies build on one another, such as they best discussed in sequential fashion, starting with the general structure or architecture of the internet. LANs and WANs and the specialized equipment such as NICs, routers, gateways, and firewalls used to control the flow of information between computers and networks. The components you have already read about are what make the hardware of the internet. To understand how the internet works and hardware level, you need to learn little more about these pieces of equipment. However, before you can understand these specialized network devices, you need to know about the protocols and the addressing. So the innovation of the World Wide Web in 1989 by Tim Berners-Lee, a British computer scientist, revolutionized the internet and made it more accessible to the general public. The web allowed people to easily access and share information using a simple user-friendly interface. Today, the internet has become an integral part of modern life, with the billions of people using it every day for everything from communication and entertainment to commerce and education. Its impact on society has been profound, transforming the way we live, work, and interact with each other. So in Module 8, it is the continuation of the Module 7. On this module, the discussion will cover the continuation of the topics about the internet. The topic that will be discussed on this part will cover the chat and the instant messaging, the experience of the web, and the navigating the internet. In this module also, it discussed the different parts of web server programs. The HTML. HTML is the language web browser used to display web pages. Normally, HTML pages are static. They never change from one request to another. To make information on a web page dynamic, that is, have it to different each time it's accessed, you need a technology with more programming capabilities than the simple formatting available in standard HTML. In XML, the original specification for HTML was derived from a document specification for SGML, Standard Generalized Markup Language. SGML is not a markup language like HTML. Rather, it's a specification for what a markup language should consist of. HTML has been enormously popular because it enables people to format web page in appealing ways. However, HTML deals only with the form of web page, not its content. New technologies related to the internet are described in the online chapter, Emerging Technologies. One thing is certain, the internet is here to stay. As time goes on, the internet will become more part of everyday life. As the internet grows in use, computing professionals will be required to develop and use new internet-related technologies continually. And that's our video for today. See you on our next vlog.